So hello everyone. Before we get started, I want to make sure that you all are awake for this exciting presentation after the lunch specifically. So let's warm up. So question for you guys. How many of you think managing Kubernetes clusters at scale is challenging in production? Fantastic. So I see many of the hands raised. So you are in the right session. And I see few of them did not say yes, but still you are in the right session. So I'll say why. My name is Praseeda Sathaye, and I am a Principal Container Specialist at AWS. And today I'll be talking about how we can manage the provisioning and configuration of Kubernetes clusters using, of course, the GitOps mechanism to empower our developers as well as the operations team. So someone has said that there can be no solution without a problem, and there can be no architecture without a solution. So I'm going with that flow. As we have seen, Kubernetes is very popular, right? And enterprise customers are having this tug of war between the flexibility and the complexity of Kubernetes when running in production. Developers really enjoy the power and the freedom of Kubernetes, but the operation teams are struggling to manage these requests from the different teams to maintain the consistency and control, right? So this shift has actually given a rise to what we call it as platform engineering models. So when it comes to platform engineering, there can be many strategies, right? So depending upon the organization, depending upon the workload size, depending upon the skills your team has. But broadly, some enterprise customers, what I have seen at AWS, commonly follow these two models for GitOps as a service. One is completely managed by the platform team, where they manage and install all the GitOps solution, and the developer just comes with their application, and that's it. And this could be the reason because the developers probably not very skilled with the Kubernetes concepts, or they are only worried about deploying their own applications and functionality, and they don't care about infrastructure or anything else. In the second model, the platform team definitely manages and installs the GitOps solution, but they give slight amount of privilege to the application team over here, some degree of ownership, so that the product teams can actually deploy applications into the provision cluster using the GitOps mechanism. So we are going to talk about second case over here in this presentation. So then, what are the challenges in using GitOps as a service? So we do have tools like Terraform, right? We have Pulumi, we have CloudFormation, we have Crossplane to streamline the provisioning of clusters, right? So then what is the challenge? The challenge is how do you configure the GitOps pipeline for the application teams to deploy their application through this GitOps way, right? That is still a challenge. Some platforms team do that in a manual way, but it slows down the productivity of the development team actually. So because they have to wait for the cluster access, a lot of tickets, as one of my colleagues has mentioned, so many tickets they have to file and reach that stage, right? So that's the challenge. So what we are saying here is addressing the operational overhead involves simplifying and streamlining the onboarding process of these teams using the GitOps platform. And of course, this requires strategic approach to workload management to enable the provisioning of these workloads at scale. And this might also require configuration management best practices, but that automate the life cycle of configuration and upgrades actually for these clusters through the centralized source of truth, right? So how do we do this? Let's dive into that. So before I move into the solution, I just want to define the solutions or the software CNCF projects that I've used here. I know most of you are familiar with this, but I have met with few folks who are still new to this concept. So I just want to define very briefly. So Crossplane is a open source cloud management tool that you can see here that enables you provision and manage your cloud resources like databases, containers, storages, and everything using the multiple cloud providers through Kubernetes API. And next, you can see over here in the picture is Argo CD, of course. We all know it's a continuous delivery tool to implement the GitOps in Kubernetes applications. And then we have Argo Flow over there, which is an open source workflow engine that consists of series of steps. It can go in sequence or in parallel. It uses basically Kubernetes pods or containers to execute these steps. And then Argo Events. It's a event-driven workflow automation framework, and that's also for Kubernetes. So with that, let's see like all these powerful CNCF projects, how we can bring them together. So in the left-hand side, if you see, you can see that it's an account team, which is dedicated to the platform team. And they are the owner of this management cluster, what you see over there. So this is the team which maintains the guardrail and the golden path for all the other infrastructure resources that they provision for the other teams. And on the right-hand side, which is a different account, which is for all the product teams and dev teams they are. And those are the ones who are actually wants to deploy applications in their environment using the GitOps way. And that is their expectation from this product platform team, right? And then we have the centralized Argo CD over there. We are using the hub-and-spoke model over here, and which means that the same centralized Argo CD instance will be used even for the management cluster, as well as the clusters which are actually created for these development teams over here. So in this management cluster, currently, we have already pre-installed Argo CD as well as Crossplane. It's already done over there. So now let's start with the flow. I know it is very small. If I can point to you here. Yeah, so this is the flow one where the product engineer of this product team comes over there and actually creates a claim, Crossplane claim, and pushes it to this management repository. So we have two repositories over here. One is the management repository, which has all the artifacts of deployment. And we have another like application repository. We'll talk about that later. So we have followed the best practices of GitOps to keep these two repositories separate. Now, Crossplane claim, as probably most of them are aware, is a template used by the development team to actually send the request of what infrastructure to provision. And the platform team is responsible for creating the custom resources for these claims. And it might have like databases, security, like IAM and all those databases, everything. It might involve everything. So it all depends on the platform team how they composite these resources, right? So now this developer is just pushing the claim over here. Argo CD actually picks up that claim, sends it to the Crossplane. Crossplane actually starts creating that EKS or Kubernetes clusters, and it spins that cluster in this other cross account over here in the product team account, right? Now, if you see over there, we have Argo event, and it's listening to the Crossplane claim event. And when the Crossplane completes the creation of EKS cluster, this event triggers the Argo workflow. And if you see here down there, this is the Argo workflow, which basically what it does is it configures a newly created cluster and registers it to the Argo CD instance, which is a centralized Argo CD instance. Everyone is going to use that one. So then after that, the real magic happens over here. Now, the new repository has been created by the workflow, which can be used now by the product team. Right? They can actually manage the cluster as if like it belongs to them, and they can deploy applications and everything over there. So if you see also here, this newly created cluster is also associated or linked to the Argo CD. As we mentioned, it is centralized. And this Argo CD also has registered the newly created EKS cluster. So the link over here you can see, right? So that's what it happens in this solution. Now let's drill down more into the workflow, what happens over there. So the first step of the workflow is API call, basically to the Argo CD, over here to register the EKS cluster or Kubernetes cluster. And since Argo CD needs to access all the cluster with another AWS account, as you saw over there, it needs to create a service account now inside this new cluster. So the service account is granted all the necessary permission actually to interact with all Kubernetes resources within that cluster. And these credentials from the service account will then be registered in Argo CD. So that is how like Argo CD gets permission to execute or do things in the cross-account cluster. Okay, and then we have the next one is like the creating the OIDC group to add users. So in this, like we are using OpenID Connect group, which is created, and we have used Cognito over here. Cognito supports OpenID Connect, and we have registered the team of the product users into that OpenID Connect. So that's the process it does over here. So this dedicated OpenID Connect group serves as a gatekeeper, granting its member the privilege to manage this new cluster. And then we have the third one, where we are actually a dedicated repository is created in code commit. You can use GitHub also. Here we have used code commit. And this repository is connected now to Argo CD. So this step is important because now this newly created repository will be accessed by the product team to manage their own applications, right? So here we are using the concept of GitOps project, as everyone would be knowing. It's like a multi-tenancy. So we are basically ensuring that only the users of that product team can access the cluster and also can access the Argo CD UI. So that part is done over in this step. And then last, we are going to actually, oh, I missed the part. Like we create a repo and connect the central CD, Argo CD instance also with that repo so that Argo CD can actually get the information from that repo. And the last one is we are bootstrapping the repository, which we just created in code commit with all the basic applications what the developer might need. It could be a fluent bit, it could be secret operator or anything what they need to run. Actually, the development team might need to run later. So that bootstrapping is happening. And now we'll jump into one of the code snippet of Argo event. Here, we are showing the event source, which captures the cluster creation event in the form of config map. So what happens is like this config map is deployed as part of the crossplane composition. So, and this config map has all the information of EKS clusters, which will be required by the next thing, which is Argo Workflow. So Argo Workflow is waiting for this config map and doing the rest of the things, what it has to do. Now, if you see the Argo Workflow here, it has the steps, whatever I specified in the workflow slide before. So I won't go into the details, but I just wanted to show you that this is how you define all the steps in the Argo Workflow. Okay, so we are just diving deep into the first step over here, just as an example, how it looks. Here we are looking into the register cluster in Argo CD task of the workflow. So this task has an image, if you see over there, and this image has all the software that is required to execute that workflow. So in our case here, we just need AWS CLI and Argo CD CLI. So that is what we install inside the image. And then from the line 310, what we are doing is the script is workflow script is getting executed, and it's first retrieving the kube config from the newly created cluster, which we have just provisioned using Crossplane, and then we log into the Argo CD using the Argo CD CLI, and then we finally add the cluster. So that's the process it does in the script. Okay, let's jump into the demo to see like the whole solution in action. In the interest of time, I have recorded this demo, so I guess the blessings from demo god are already with me. So, okay, I'll just go along with this. So the first thing what you see is the management cluster over here, and this is the repository, code commit repository. And you see all the components of code commit repository over here, which has like Argo CD, which has Crossplane, and all the Bootstrap application also. And then we go to Cognito, which we are using as the identity provider here. And we can see like all the users in the Cognito, like for that group, specific groups, right? So we have defined all the users over here. And if you see the group, right now we are having only one group, which is the platform teams group, and where the current user who has logged in is part of that group. And we have also connected the Argo CD, wired up over there so that the users can log in to the Argo CD UI using this OpenID Connect. So and you don't see anything in the workflow right now. And in the Argo CD application, you see all this application, which I mentioned like was in the repository. They are actually deployed over here. You can see load balancer controller. You can see all the Fluent bit, and all those things are already installed in the management cluster. And in the repository, currently you see only one repository, which is the platform teams repository. And then in the cluster, of course, you see only one cluster, which is a management teams cluster. And now in the projects, you can see like only the default project is there. And you can see this is the user which belongs to the platform team and is the one who has logged into the Argo CD. And now let's go inside the console and see what we have over here. Okay. Oh, sorry, where was I? Messed up. Okay, sorry about that. So here we are inside the console and we are seeing the Crossplane composition. And if you see over here, this is for EKS cluster where we are specifying the networking, Kubernetes version, all the information that we can supply into the composition of Crossplane, right? Now, next what we are going to do is we are going to trigger the event over here. Okay, before triggering event, like since I mentioned the config map, right? This is what the config map will have. It will have the cluster name, it will have the account ID, product name, and the product users information. So we are using this config map to give this to the Argo workflow, right? So we need all this information captured. So that's what we are doing. So as part of the composition, we are also deploying this config map. So we are actually simulating the cluster creation because it takes a long time. So we already did that. We are just simulating that the config map is created as part of that. And now if you go back and see now what happens, this Argo workflow is working over here to execute all the steps what I told before. It might take a minute, but in that meantime, I want to explain that Argo CD has like RBAC, two types of RBAC, right? One RBAC is for control, Argo CD control plane RBAC, and another is for Kubernetes RBAC. The first one is used for the users to log into the Argo system, like either using CLI or using the API, right? And the second one is used actually for Argo CD to access the clusters which it creates. So there are two topics. And those RBACs are currently working in the circle it is going right now. It is giving the access to both those RBACs so that everything can work correctly. So the way of what we have done is like we have done the execution parallel so that it can be faster also. So that is one benefit you get from the Argo workflow. So it will take, yeah, so everything is done now. Argo workflow has completed. Now we'll go back to the, again to the Argo CD and to the code commit repo. And we see that like we have one more repository over here, which is newly created Git code commit repository. And the application team has this already application, which is bootstrapped already for the application team. And now we are in Cognito, and we are seeing like the groups. You saw before one group. Now there is another group which has been created for the product team. And these are the users who are part of that product team. So this has been done as part of the workflow. Now you go back to the applications, and you see over here the repository. You should see two repository. Earlier you saw one. This is the application repository over here. And going back to the clusters, you see like now two clusters. The second EKS cluster also is seen over here. And then the last one is the projects. I said that this is used for multi-tenancy, so that project is also created for the product team over here. So that was about all I had for the demo. So it is just showing that all the applications, the Bootstrap application is also as part of that. Oh, one more thing. Now we are going back and logging as the product team user. And now you can see like your own Bootstrap application. You don't see anything else because that's the multi-tenancy part. Now this is the product team's login, not the management platform team's login. So they can see all the applications that they can deploy, and now they can manage through the GitOps way. Okay, over here also, there's no clusters because we have not given access to them. They can only do through the GitOps mechanism. So that's, I think, what I had. Okay, so now in the demo, like I showcased one of the solution pattern to overcome the challenges that I mentioned in the beginning in terms of operational overhead, workload management, and configuration management, right? When you are specifically building the platform engineering journey. However, when you want to build that platform, there are numerous CNCF projects available that you can leverage, right? Now the question is like, which one to pick and which open source CNCF project to adopt. So that's a big challenge. So to address this, I want you to all to introduce this to Canoe, an internal developer platform distribution built in collaboration with the open source community. So AWS has collaborated with several strategic customers to design an opinion-based development model. And in this model, we have integrated tools like Argo CD, Crossplane, Backstage, Argo Workflow, pretty much a lot of things which I talked about today. And we have created a tooling around that that offers you like a pre-configured developer platform that you can set up very quickly. You can learn more about this in Canoe documentation over here. And there's also some reference implementation, the second link, where you can see how Canoe is used. So that is also available. So with that, I would like to thank you all for attending this session. And if you have any questions, you can reach out to us via email, or you can also ask me now. And we'll put this sample and code repository like very soon in AWS samples so that you can take a look how it works. So thank you.